Good morning, everyone. Can you all hear me? Great. My name is Narayan. I'm from the Azure networking team. And for the last 30 minutes or so, I've been wondering, what are you all guys doing over here? It's the second last day of the conference, the first session. The weather is great outside, and you all want to know about virtual networks and security, huh? All right, so be it then. So without further ado, let's jump in. So this is going to be the agenda, different things we're going to talk about today, right? We're going to talk about virtual networks, what and why, what's new in this exciting space, and I'm going to talk about security in Azure, an overall view of it, and going to focus more on security on the network side of things. I'm a networking guy. I mean, that's what really interests me. So I'm going to talk about from that perspective. I'm going to talk about some exciting things that we have done to the platform, including the user-defined routing and IP forwarding, and how that actually enables you to customize this network to your needs. And we have a partner who's going to show a wonderful demo, and we're going to hear from them. And I'll wrap it up, right? But my real agenda, guys, today is two things. If you're already using our services, you're already deployed into the cloud in Azure, I'm going to give you a few more reasons to smile. Think of how smart you are. Second, if you're not there yet, I'm going to try and push you over the edge and see if I can convince you, right, to move over to the cloud. And if I can't, I'd like to hear about that. Towards the end of the session, please grab me and let me know why you still can't do this or what's still lacking. I'd like to hear from you. Okay, let's jump right in. This was not even in my slide originally, but I can't go past this thing. I was so wowed by this, I thought, I should talk to you about this thing. Why cloud? Why come to Azure, right? In spite of all the other things that we actually offer you, what really is amazing is the scale at which we enable you to, right? It's a huge scale that we are actually that you can actually go push yourself to. The Azure network has 85 connection points with internet service providers, and that connects to like more than 4,000 networks. Right? We have 19 regions. That is what AWS and Google put together, right? We have huge data centers, racks and racks of servers. Right? And just the cable that we use to wire up these servers, you can wrap around the earth 4 times. You might have heard this before in this same session, in this conference. I don't mind repeating it. This really wows me. That's the scale at which Azure is like building its stuff. And we are doing big investments in Azure, right? This is something that you cannot do if you're doing it privately on your own. This is what we want you to enable. We want to enable you to use the scale, right? Now, how does this all matter to you? How does it apply to you? Now, that's the most important thing. Let's look at that. When I say we, it's Azure, but more so from a networking standpoint. This is how we look at things, right? So you have your on-premises. You see those buildings over there, and you are there. You are deployed. You're happy. If things are working for you. When you come to the cloud, we want to provide you the same familiar concept, the same knobs by which you can operate your networks. And that's the virtual networks for you. We want to let you create your own network, customize it to your needs. We do understand that you will run a lot of services in this network, and you need to connect to that from outside, from inside, and back to your on-prem. So we offer all these different services to you, right? From the outside, we give you a direct internet connection to your services, right? We give you load balancing. We give you DNS services. We give you DDoS protection. So that is all you need to connect from outside to the services running into the virtual network. And inside the virtual network, we let you customize your network. We let you define what address space to be used. We let you segment your networks. We let you put ACLs and rules and routes and how packets should flow inside your network. This is your own network. And when you go back to the on-premises, we give you more than one option to stay connected with on-premises, right? This is how we see things. And let's now delve a little bit more deeper into this virtual network and then see in detail what are the different connectivity options. So before I start, actually, let me ask you, how many people in this room use virtual networks? They're familiar, you use it today? Yeah, except for my colleagues, I'm going to ignore them. So it's still a good number of people who use virtual networks. But for others, just bear with me for you, made repetition, but others, I'm going to spend a little bit of time kind of telling you what this virtual networks actually is. What you see here is a very abstracted very simplistic view of your on-premises networks. This is not exactly what you have, but just a representation. So bear with me over here. What we think is you have an on-premises network, the box that you have there, right? You have your routers that connect you back to the internet. Just on the front edge, you have web firewalls, and this could be really hardware devices that you have there. And then you have your front-end layer, where you run like web services, your DNS services, and AD and all those things. And then you connect back to your back-end layers through a hardware load balancer. This is probably what you have. Now, when you come to the cloud, how does this translate? What becomes what, right? So the on-premises network that you have is actually your virtual network. That is what you're creating in the cloud. We tell you, just create a network, just like you would create a network in your on-premises, call it your own virtual network. You don't need those routers, those hardware devices. Azure infrastructure connects you back to the internet, both inside and outside, right? You don't need to have any of those web firewalls. You can use software-defined concepts to do your security. We have things like network security groups, where you can really put your rules and configure them, right, and get whatever things that you want to block or allow. And you don't need any of the hardware load balancers. We have, again, software-defined load balancers in Azure that you can leverage to have your high availability needs satisfied. So what does virtual network really give you? It's a trust boundary. I mean, this is your space where you come and specify what your address spaces are. You then go and do this segmentation of it. You divide them into subnets, right? And then you bring your own DHCP options, just like you will do in your on-premises network. Bring your own DNS servers. Specify what IP address to be used for each virtual machine that you have, right? And use concepts like security groups and route tables to customize this network on who can talk to whom and how does the packet traffic flow from one place to the other. That is really what it is, right? We want to give you the same familiar concepts and knobs and controls as you would operate on your on-premises network. We give you all that in your virtual network, right? So let's find out more. There is a typical application pattern that we see. Talking to customers, what they have, what they actually use it for. It's a typical application pattern. I'm not going to go too much into details. But again, there is a layer, which is a DMZ layer, where you connect from the internet. This is typically where you run your web front ends. And then that talks to a backend layer, where you could be running your databases or your app servers. And you need high availability here as well. And eventually, you connect back to your on-premises. This is a typical application pattern. So what I want to really show here is like there are 3 different layers. And let's look into each layer. What do we provide to let you run your stuff in Azure? The first is the internet connectivity. What are the different choices and options over here? So some of the stuff I'm going to talk about are kind of a recap. So this is not literally the latest things that we're announcing, but some of them are the newest abilities, right? And whenever there's a new ability, I'll have a new on the top, and I'll make sure to mention that as well so that you know there's actually new. This is stuff that we always had. I mean, we have this for like more than a year now. So connectivity from outside, you can do it through 2 things, right? First thing, you need a public IP address. That's how you can connect from outside. But we give you choices, right? You can take this public IP address, you put it on individual virtual machines that you have in your network, or you take this public IP addresses and put them on load balancers. When I say load balancers, these are Azure provided software load balancers. You put it on them, and then you set up your load balancing rules on how this traffic should actually go to. You can go to a set of VMs or another set of VMs, right? And then you specify your traffic rules as to whether it is like a hash-based load balancing algorithm or it is source-based. And if it is source-based, how many tuples you want us to do. We have different options here. We also let you customize the timeouts. When you connect to from outside, how long does this connection actually stay alive when you're idle, right? You can play with the idle connection timeouts. You can do all these things, right? And the good thing, you can use both. You can use both. And there are applications and services that make good use of both these technologies, right? So you have a front-end service that you want to be highly available. You put them behind a load balancer. But after people connect to you, then you spawn off a separate new internet connection with just one virtual machine, right? And FTP servers and things of this nature use this technology. So they can use both in conjunction or in isolation. It's up to you, right? And as I talk about these different ways to connect, I'll also tie back later how you can protect them, how you can secure that further, right? This is going to be a security talk after all, so I'll have to tie it back to that as well. So This is the new feature, right? So I talked about like two ways of connections. One is load balance and the other is like per instance on the VM itself. Now, you can have not just one front-end IP, but multiple. You can have multiple front-end IPs to the same set of VMs on your back end, right? And great use case is running multiple HSL websites. Let's say you are an ID shop or you are your front end for your company and you want to run a service for a lot of your other teams that is there in your company, right? And everybody wants to run an HSL website. Everybody wants their own IP. You can now do that just with the same set of VMs, right? The content could be the same or different, and you can just give them each one different public IP and have them all come on port 443 on the front end, and you can load balance that to different set of VMs or same set of VMs, right? So that's a new ability that we're adding. It's a pretty good one. And the next is reserved IPs. This is actually existing, but let me tell you what is new here. So you people might know about reserved IPs, right? So this is like you come to the platform and say, I want to have an IP that is not going to change. I want a static IP. I do not like this when I delete my virtual machine or service, I lose my IP, and then I redeploy it, I get a different IP. Now that just changes the whole thing for me, because the way you connect outside, your IP changes. And sometimes people are connecting to you based on IP, then you got to go flush all their connections to actually point to the new IP. So we understand. So we let you reserve IPs, that is on your subscription, that you can use. The new ability is, though, you can move that. You can move this IP within less than a minute from one service to the other, right? So this IP was used to service A, and let's say service A goes down. Within a minute, less than a minute, you can move that to service B. So now, the IP doesn't change. People connecting to the same IP are now directed to a different set of VMs. That is new ability that we're actually announcing. Another thing that you need to note here, right? And this is again based on feedback. You all said, that's great, but I don't want to reserve a new IP. I want to reserve the IP I'm using today. For some reason, you all like the IP so much. Okay, fine. We'll let you do that also now. You can just take the IP that is there on your service right now and reserve it, and then use it, move it around machines. So that's a good ability. This is another one. This is actually my favorite. So as small as it is, that's a very good use case. Right now, there is public IP. What I mean by public IP is you can take an IP and put it on a virtual machine directly. We did not have any kind of DNS names for it. So we told you that, okay, you have an IP on the VM, use this IP and connect to the virtual machine. That's working fine. I mean, there's no issues with that. But the discovery part here, right? So you will have to deploy and then find out what the IP is and then connect. And there is no way for you to just have some people may remember IPs really well, but for others, I mean, it's not quite straightforward to just keep remembering this IP that you have for this virtual machine. Now, we actually register a DNS name for this IPs. And the good part is, if you're putting it on a cloud service, which is going to expand and shrink, we automatically register and deregister these names. So like I show here, you have a contessor at cloudapp.net. Let's assume that's your company, right? That is your name. That's for cloudapp.net. And now you want to say, I have this set of VMs, I'm using like a web role, and you can provide a DNS prefix for that. Call this a web role, right? And then you're going to shrink and expand. You're going to like increase or decrease the number of instances based on the load. And we find out, and we register a DNS name for every one of those instances. So here, instance number 1 is webrole.0 dot your suffix. And the other one is webrole.1 your suffix. And let's say tomorrow you want to expand this, and you make this 5 VMs running in the cloud service, just doing one configuration change from 2 to 5. We're going to come up with new names. Webrole.2 dot, webrole.3 dot, webrole.4 dot. Now this tells you the discovery up beforehand. Even before the VM is alive, you know what name it's going to have. That's auto discovery. This is very good, right? Now, that's all about internet connectivity, right? This is very, which we wanted to highlight. I mean, there are a lot of other things. I mean, there are a ton of resources that you can actually read to find out. But now let's move on to what do we provide for internal connectivity. When I talk about internal connectivity, this is about like within your virtual network. What do we let you do? And what is new here? What is changed here? Multiple network interface cards per Azure VM, right? This is not a new feature. I mean, based on popular demand, we released this like about 6 to 7 months ago. What is new here is we have increased the number of NICs that you can have. It used to be 4 max. Now you can have up to 16 network interface cards in a VM. Anybody need more than that? Oh, some people do. All right. I guess there's no limit for anything. But anyways, this should satisfy most scenarios. 16 network interface cards is what you could have in a virtual machine. And there's another new thing over here. Every network interface card can have a security group. So before, a security groups could only apply to the primary NIC. Right now, we have made sure that you can specify a security group and security rules on every NIC. So a single virtual machine that is part of a virtual network can have, let's say in this diagram, 3 NICs. Each of that NIC actually be part of a subnet, and each of those subnets can have an ACL group. And each of the NICs can also have an ACL group. So you can really restrict the traffic that is flowing in from one NIC to the other NIC. That is what is updated over here, right? The next, it's one of my favorite features also, is internal load balancing. Nothing new here, but I thought this is worth mentioning in a slide because you can, for all your services, there is actually internal facing, right, or corporate facing or intranet facing. You want high availability, and we do provide load balancing for you. Just to have your high availability services run on a secure environment. You can specify what IP address to be used. That is going to be from your network space, right? It's going to be from your subnet. You can be very prescriptive that this is the IP I want for this service. And this IP is going to be reachable from all of your virtual networks, right? And from your on-premises network, and from other interconnected virtual networks. It's accessible in all these layers, right? It is not accessible from internet. We cordon that thing off. It's only accessible within your environment, right? And even to put more security, you can even come up with a security group and put rules on that. But by default, this is only visible within your virtual network and your interconnected virtual networks and your corpnet, right? That's the thing here. It's been there in use. This brings to life a lot of scenarios like SQL always on, where you don't want your SQL service exposed to the internet, but you want high availability. So I can give you a number of examples of why this is useful. Quite popular feature. Most people use this. So just wanted to mention that. The next, this is the new kid on the block, right? User-defined routes. You've been asking for this for a long time. We know that. We heard you, and here we have it. And I just want to spend a little bit of time explaining you what this is and how powerful it is, right? By default, as you see the diagram, if you have a virtual network, if you have subnets, and if you have virtual machines in them, we provide default system routes to route between these VMs, route between the subnets. You don't have to do anything extra. There are routes already in place for you to take you to the internet, to connect between VMs. We have those specified. But now what you can do, you can specify routes and put something on the way, on the path, right? You can bring a virtual machine, which is usually an appliance, but even just a regular virtual machine can be placed in the path between this VM's communication or VM to internet communication, right? You can interrupt this path both on the internet edge or on the internal side of things. So we give you just the same concepts like how you will define a route table, right? You can specify the destination prefix on where this route applies to. You can specify the next hop address, right? And sometimes it could just be a next hop type. For example, if you just want to route everything through our gateways, the gateways that we provide, you can just say the next hop type is a gateway. You don't even have to worry about what IP address it is. Or if you want to bring your own VM, you can say the next hop type is a virtual appliance, and here is the IP address for that, and we'll route the traffic to that specific VM. And you're going to see a demo of this today, right? So this is what our partners, we have a good virtual appliance ecosystem, and our partners are building on top of these features. And one of those partners are here today with us, and they're going to talk about what they have done and show you a demo, right? So one use case or one common example of where this is used is force tunneling, right? We all know that like corporates want to force tunnel all their traffic back to the on-prem in certain cases. Certain subnets are so secure, they don't want this traffic directly hitting the internet. They want this to take to their on-premises, do whatever filtering or inspection they want to do, and then send it back to the internet. They can use this. They can just simply define a route called as all traffic on this subnet. Now, note that, just this subnet. You don't have to do this on all subnets in your VNet. You can pick some subnets and say, this particular subnet, all the traffic 0/0, the next stop is my on-premises IP. And we will, through our gateways, we will deliver that over there. You can then connect back to the internet, and then you can, the return traffic will go back to you, then you can bring it back through the tunnel, right? This is a common use case. So I just want to mention that use case. But then there's many more, right? I just want to mention this one common use case, but you'll hear from yesterday there was a session on what different offerings we have, and today you'll hear more. And there's another slide where I'll talk about other use cases. This is a feature that we always had, but again, just like internal load balancing, this is important enough to be mentioned in this context. So you can not just be having one virtual network, you can connect all your virtual networks in the same region or across regions, and they're all secure. They are encrypted, right, through our gateways. So you have a secure connection and communication, and by which you can build a global network in Azure using virtual networks and interconnected VNets. So just wanted to mention that. Then another element that I wanted to cover today is the management aspects. So I talked about, like, once you have the virtual network, what really happens, right? But how do you connect into this virtual network? Like, what APIs do you use? I mean, what is there Portal or PowerShell or what, right? And there is a new thing right now that we've introduced, and I want to take some time to talk about that. We have something called as Network Resource Provider, or what you would have heard about this is called as Azure Resource Manager. Have you been to those talks knowing about ARM? How many of you? It's okay, it's a good number, but there's still a lot of people who probably not familiar with this yet. So we have something called as Azure Resource Manager, by which there's a new templatized way, a JSON-based model to connect to the Azure environment, right? And the big benefit to me, the biggest benefit of this is you have really, really granular API access now. How many people have complained about there's only one command for me to play with virtual networks, that is set network configuration, right? Yeah, I can see a lot of heads nodding there. Yes, so we used to just let you define the network once and update the whole network, like all or nothing. That's changing now. We give you granular API access to control a virtual network, a subnet, a network interface card, a security group, a route table, a route. Every single one of those entities is going to be a top-level entity that you'll have direct APIs to control. That's the biggest benefit of this. The next biggest benefit, you don't have to worry about, like, doing multiple calls, right? You can build a powerful template. You can define everything at once, and we have a lot of samples available already, and you can build one. You can take the base of it and you customize it to your needs, and you can just build a very powerful network, define the whole VNet, subnets, your security groups, routes, and all that in one go. Boom, deploy. Within seconds literally, you will have your VNet created with all the security stuff there, right? With all your subnets, with all your routes. Then you can just start deploying VMs into that. That is the ability. That is the ability. That's a question from my colleague.
Do I have to hire a developer to do this?
No, you don't have to. So we provide you with templates that is already there, like I said, that you can look at and build on top of it, right? There is going to be a portal that is going to also make it easier for you to deploy, and just a lot of samples, which is so easy to understand and build, and so intuitive and logical that you can do it by yourself. And there's going to be Visual Studio integration as well coming through, by which you can kind of do a drag and drop experience as well, right? To really put together powerful, complex network scenarios. It's never complex, but some people like to say it's complex network scenarios, so okay, all right. So even to do that, you can use such templates. What are the benefits? Number one, the other benefits, right? We have, like, audit logging now, right? So we support logging. So everything that you do with this platform, there is a log, and you can go see that, like who did what, right? That audit logging capability is there. And the most important of all, RBAC, role-based access control. I mean, I can't count the number of times I was in a customer call who have asked me for this thing, right? I just can't imagine that, like, everybody has the same privilege in Azure. Yeah, okay, we heard that. So we have RBAC in Azure now. You have role-based access control, right? So you can define custom roles. We have built-in roles. We have like 20 built-in roles. If that works for you, just use that, right? Your administrator, your owner, your observers, your all that. Or you create your own roles and give them fine-grained control. This is to a level where you can go to this APIs, each API, right? Each REST URL, you could define a privilege on that. You can say, this guy can look at my VNet, but he can modify. This guy can modify my VNet, but he can deploy VMs into that. Just giving examples. This guy can use security groups and apply it, but he can define his own security group. You can just customize this to whatever you want, right? It's a very fine-grained API level control that you can achieve, and you can put that on your environment, and it just works. It's great. Another important thing. Now, what we do is like for every subscription, we kind of have an Azure AD that is we created in the background, right? And then you can define a variety of such things. Like you have owners of subscription, you have like people who can manage all your VNets, people who can manage all your resource groups, or only this service in a resource group. I mean, there's a lot of variation that you can actually use, which is what I want to highlight. Very powerful. And once you get used to this thing, this is the way that you integrate your AD, on-prem AD to this, and then you just seamlessly, the same privileges and permissions somebody has in an on-prem network, that's the same experience they'll have also in the Azure network. Just want to highlight that. Okay. That is all about what is virtual network in the 20 minutes or so. I want to condense the version and what was new. I want to step back a bit, talk about security in Azure, right? Obviously, I can't do justice for all of security in Azure in 20 minutes. So I'm going to give you an overview, some good pointers, and I have good resources in this deck that you can actually refer to. And I'm going to focus a little bit of time on security that relates to network and to packets, right? Okay. So if anybody has any doubt that Azure may not be compliant, right, here is one slide for you, right? And not just this slide, go to azure.com/trustcenter, right? There is a ton of information on all the different things that we are doing, right, to make it more secure for you and to let you know about like what compliance certificates that we have. And what I can tell you is like with all these long years of experience of Azure running online services, Microsoft running online services, we really understand how to protect your data, what kind of data can be shared and when, and what kind of access to be given. We really get that. And there's tons and years of experience put into securing your data, which is the most important thing for us, right? So now let's focus a little bit more on how the infrastructure is protected. Now I'm kind of getting into how your network is protected, right? Azure infrastructures, like I was telling you, huge things, right? We have regions, we have data centers, we have racks of service within the data centers, a lot of networking gear to connect all these things. But to start with, very, very basically, you have a physical security, right? 24 hours. It's not that if somebody can like breach into this data center and somehow get this server that where data is held and you can run away with it, right? I mean, there are armed personnel guarding the data centers all the time, right? And we have like centralized monitoring, right? Anything happens in data centers, we have a dashboard that you just watched. There's an automatic alerts that's going on, right? Whether it is something bad is happening, something good is happening. We know everything. It's constantly monitored, right? And we have DDoS protection, right? Because one thing I want to let you know is like we run our services in the same Azure environment. When I say our services, I talked about a lot of the software-defined services like software load balancer, the virtual network management layer, everything is all running. This is running in Azure, just like one of your services. So we got to protect those infrastructure services. By protecting that service, you also get benefited. We're protecting the entire network, our infrastructure, right? And anybody who's running inside Azure is automatically protected by this. Let me give you a little bit more examples of what I mean. This is different layers of protection that we have, right? Now think about some kind of packet, network traffic coming in to the services or VM that you're running inside Azure, right? We have multiple levels of protection. We start with a DDoS protection, right? So we look at like packets, kind of attacks or whatever it is, and we have ways to detect that and mitigate that, right? And as you come inside, you have ACLs and the perimeter, right, that you can define. Then You can have like isolation on the virtual network because your network is different from somebody else's network, different customers. So we have that kind of isolation. And as you come in, we have security groups now, which is even more of a very prescriptive policies that we can apply on the packets. Then we get into a firewall level access on the VM, that is what you specify, before the packet can actually reach to your VM. Multiple levels. And I'm going to actually spend some time on each of these and say, like, what can you do to make the best out of these? How can you make this environment most secure for you? That's what I'm going to spend time on. So network protection is really like there are three things when we talk about network protection. First thing is network isolation, right? So your company A, somebody's company B. You are all running your networks on my infrastructure, which is common to everyone, right? So something must be happening here, right? Like I have only one network, but I'm hosting different of your networks. I got to isolate that. That's the first thing I do. I have means to isolate virtual networks from the physical network. The same physical network can be used to run multiple virtual networks. I have network isolation through virtual networks, right? Second thing, I have isolation on different services. I also know, even within the same network, for example, right? Service 1 talking to service 2. I have to isolate the services. I got to see whether it's allowed to talk to each other before I let this connection happen. The service level isolation, right? Third thing is network to network isolation. Maybe it's the same company, same subscription, right? You have 5 different networks, right? I then still have to apply rules to determine whether the network 1 can talk to network 2, right? So these are the different types of isolation perimeters that we have and abilities that we have to specify specific rules on this. Now, before virtual networks, even with the exist, let's talk about how service isolation happens, right? So Azure has been running for 6-7 years right now, right? And virtual networks has been a concept only for 3 years. So before that, I'm sure you're wondering, how do they isolate stuff, right? I am Pepsi, and how do we know that my packets are not going to Coke? It's a common question that many people have, right? Let me give you a little bit of information on how we do that. So in this picture over here, you see that when I say a blade is a physical server in the data centers, right? It's a physical node. And this host runs multiple virtual machines, right, managed by Hyper-V. That's the setup over here. Let's assume there are 2 customer tenants, right, customer services, one running on blade 1, other running on blade 2, right? Now, this customer 1's service running on blade 1 wants to talk to customer service running on blade 2, right? Sure, he wants to talk, so he just sends the packet out. There is no protection here. The packet goes out of his blade, right? But before it can go to the customer 2's VM, there's a hypervisor firewall, right? So we have our own security rules that we have specified that has the notion of like what service is this. So when this packet goes to the hypervisor firewall, it's looking at it and saying, okay, you are service 1. This is different service 2, right? And this hypervisor firewall per virtual machine. You're not allowed to talk to this guy. The packet is dropped right there at the network level. It doesn't even go into your virtual machine, right? And if it does, I mean, if it doesn't, let's say you put a rule to allow it, right? Then it goes inside. You have a guest firewall that you can actually block it with, right? This is even before virtual network. This is very, very basic stuff, right? A different diagram. Let's say they are in the same physical host now, right? And this could happen. I mean, one physical host can run multiple virtual machines. It so happened that service 1 and service 2 landed on the same physical host. Then you must be wondering, the same computer, the same. So maybe they're talking to each other. No, it still goes to this hypervisor firewall. So what we have is we have something called as a VM bus, right? Like where the packets going from one VM to the other VM go on to this hypervisor firewall, hypervisor layer, kind of is routed through the bus before it goes to the next VM. And before it is routed, there is a firewall that comes into the picture over here, and that applies the rules, and the packet is still dropped. So you're still protected, even if you're running services with other customers on the same blade, you're still protected, is what I want to kind of convey here. The next is, let's get into our favorite topic, virtual networks. This gives you the isolation now on a network level, right? Now you're building logical boundaries saying, yeah, I have 100 services running on Azure, right? All of them are on virtual network 1. They all should have like trust each other. They all should be allowed to talk to each other. Sure. That is what the virtual network actually gives you, correct? So now, Can everybody in the virtual network talk to you, or do you want to restrict people? Well, you can restrict people now using security groups. You say, oh, I have different subnets. My subnet 1, I can trust that guy. I mean, he's really the backend subnet. He can talk to subnet 2, all right? So you can specify rules that allows anything in subnet 1 to talk to subnet 2. But there's subnet 3 that you don't, not about trusting so much, but these are like front-end services. You don't want them talking to everybody else in your virtual network. Okay, define a security group and block them, right? So now, with this granular security controls, you can do things like DMZ. I mean, you can really have a section of your subnet or your front-end servers that you can put on front-end subnets and define security group rules such that they're only allowed to receive traffic from the internet, right? But not allowed to talk to anybody in your backend network. Or you can just allow them to talk to only one subnet in your backend, right? Just tons and tons of possibilities here. What it comes down to is, we let you do a 5-tuple based ACLing, source IP, source port, destination IP, destination port, and protocol. And we also let you weight this, saying with using priorities. You can tell us what you want to apply first, right? And if this rule is satisfied, we're going to take that action. And the rule is not satisfied, we're going to go look for more rules to see whether we can do a match, right? So you pretty much like design this thing and tell us how you want security to be applied. What we do is, we give you the right interfaces to attach to. The interfaces are a subnet level, or a virtual machine level, or even a NIC level. So you can put your security on different levels, right? So you can do it on subnet, or a virtual machine, or a NIC. And the best part about this is, unlike your on-premises, if you want to update these rules, maybe you want to go and meddle with a hardware device here, or hardware device over there, none of those, right? Since this is all software defined, you come and change your rules on the security group one time. It just applies to everything that is running on the subnet for this thing. So security group here, 1, is associated with subnet number 1. You change the rules, every single VM on the subnet 1 immediately gets that refresh, right? No hassle. And as you deploy new VMs into the subnet 1, they all get the same, they inherit the same ICLs and policies. So define it once and use it multiple times. That is again the scale of the cloud that enables you to do these things. You define it once, it just applies to your entire environment, right? And taking another closer look, what I really want to focus on this thing was like, you have, let's say this is a virtual subnet, and you have 2 different virtual machines over here, and these VMs are different, let's say, right? One VM, you want to even more ACL it down, and the other VM, you're just okay with the ACL at the subnet level. And you can do that. The first level is, as the packets come to the subnet, they go through this, the ACL that is defined on the subnet level, right? And if they pass that, then it's sent to the ACLs onto the VM, and then they are applied over there, right? And for the VM2, you're okay just with the ACLs defined on the subnet, and that's what it is going to be, right? So my point here is, you can have a perimeter level ACLing that applies to all services in the subnet, and then you can customize it to a very specific VM. Not just VM, you can customize it to a specific NIC. So you can just do layering of security like this, right? Your perimeter security first, then your second level of security. And all that is available to you right now because we support security groups on subnets and NICs. So, network appliances is what I'm going to talk about next. So, as much as flexibility that you have over here, if for some reason, right, you want to customize it even more, you like your security device that you've been using on your on-prem that you want to move over to the cloud, right? You can do that now, right? Like I talked about user-defined routing, that really allows you to customize these appliances to run on your virtual network. So what is really this virtual appliance, right? What do you use it for? So you can now make it work for you for like application delivery control, where you have some kind of traffic management that you want to do on certain policies, right? At application level policies, right? Not just layer 4. So the load balancing that we offer is a layer 4 load balancing. Let's say you want to do layer 7 load balancing. You want to do cookie based affinity, or you want to inspect into your like source traffic or your packets before you send it out to your backends. You can do that. You can do a NAT device. I mean, before packets hits the internet, let's say you wanted to go through an appliance which is going to NAT it for you. Sure, that's another use case. And let's say you want to bring IPS IDS devices before the internet traffic hits your services. You want to inspect them, for for intrusion detection, intrusion protection. You can do that. I mean, just variety of things. Now, one of the other common use cases is application firewall, right? So you want to really inspect these packets at an application level and then decide whether they should go to the subnet or not. And then if you don't want it, just drop it or then allow it. So there's various different use cases. And we have a good ecosystem right now where the partners are building on top of our fundamental offerings, our infrastructure, to provide you these specialized services, right? And here is a list of all our ecosystem partners, and this is not working. It is now. So here's all the list of our ecosystem partners, the different partners we work with. Each of them are building services today. They already have some services out there in the marketplace, right? It's Azure certified, Azure Marketplace. You can go download their images and use it. And there's a lot more coming on this space, right? They're all building new services on top of our new abilities. And right now, let's hear from one such partner, Aviatrix, who's shown you over here. I'm going to actually invite them to the stage and hear from them what they have done, right? What is their solution, and also see a demo, right? With that, I'm going to call Pankaj, who's going to walk us through.
Sure. Thank you. I'll just be here up for a couple of minutes. I'll give you a quick background on Aviatrix, and then Sherry, come on stage. Sherry's our Chief Technology Officer, and she will run you through the demo. So we've actually been working with Azure for a little while now, and our experience in terms of integrating to Azure has actually been very good. I mean, the APIs have been rock solid for us, and I guess we have the inside track with Narayan, so I guess that helps in terms of the support. The Aviatrix is a venture-funded startup. We're based in Silicon Valley. Our domain is aviatrix.com. We have a number of products, so I won't go into any of those, but if you get a chance, please visit our website. We also have a description of the demo back near the door to my left. So on your way out, if you want something where the demo is actually described and you walk out with it, please pick up a brochure back there, and it actually has a description of the demo that Sherry's going to do. Now, in terms of where we think the problem that we're trying to solve, we look at the cloud, and I guess a lot of people look at the cloud in terms of a distributed data center, right? And essentially, it's not that you take your data center and you move it from there to just one location in the cloud. Azure alone has 19 locations, and they're growing, I think, every quarter. You're at least adding new 1 or 2 locations every quarter. So, you have this opportunity today where you can actually move your data close to where all your users are, where all your employees are, whether they're in Asia or US or Brazil or wherever they are. You can actually move this out. But that's not the only thing that's happening. It's not just that the cloud is getting distributed. I mean, clearly that's a piece that you want to leverage. But the other piece that is happening is that the access to the cloud is getting distributed, right? So you have people that are accessing from corporate, no doubt, but you've also got people that are accessing it from branch offices and obviously from homes and coffee shops, right? And what you don't need is to basically hairpin back into the corporate through a VPN and then go out into the cloud. It means you're all trying to go out into the cloud. You really want to be able to go directly into the cloud. So you have this situation where you have multiple destinations in the cloud, and you have multiple sources where we're all trying to connect to the cloud from all of these different places. And so it's this mesh, if you will, that gets created where we're all trying to connect to the cloud. And what Aviatrix does is we have a product that essentially sits in the enterprise and it sits in the cloud. This is a software product. And we build an encrypted overlay network that essentially connects all of these different areas. So we don't just rely on, let's say, an application where, it's HTTPS and saying, look, the application is what needs to protect your traffic. We actually encrypt it down to the network layer. And so, and the way we do that, in fact, is user-defined routes, which Narayan talked about. That is how we figure out that we can be in the data path, take a traffic, and drop it into a specific tunnel, right? That's how we do it. So that's sort of a broader level in terms of where we think this is going. Clearly we think it's one way out. It makes a lot of sense to distribute your data, not just across locations maybe, but from our perspective, even within different VNets. And Sherry's going to talk to a lot of those applications. The demo that we're going to do today, let me just back up, is for a product called Cloud N. And one of the key things that we do is we take your local area network and we actually extend it into the cloud, in the sense that we take your layer 2 domain and extend that into the cloud. So in fact, your cloud resources now look like they're local resources to everything on your network, right? So to the extent that you're doing things like, maybe shadow IT is an issue, and you're trying to get to a point where you're trying to actually figure out a certain security profile for scanning certain servers. You're doing that today in your data center. Well, tomorrow you've got a shadow IT issue where you're trying to scan certain servers in the cloud. Well, how do you get to all of those servers? That's the kind of problem that we solve. We make those servers now look like they're part of your corporate network, and so you can have all the capabilities and all of the resources that you need to actually go and talk to those. So the product that Sherry's going to talk about is a product called Cloud N, and without further ado.
Okay, well, thank you, Mukesh. So, and every we are driven and custom. So we're completely customer-driven, customer-focused. We understand that this is a fast-moving industry, and on the one hand, we have cloud providers like Azure that constantly innovating and putting on new capabilities, and the business functions and business groups, they are constantly requiring to faster access to cloud resources. And on the other hand, security compliance and security breaches that security compliance is a requirement, and the breaches we hear all the time. So caught in the middle is our customers, the system ops team and the IT department, and that's where we come in to help. We work with a wide range of customers. Customers are yeah, it's okay actually. Okay. Yeah, it's okay. So some of our customers who and see it's totally liberating, and on the other hand, things seems to be very hard, and they up the environment. It takes weeks and months, and it's a frustrating experience, but we want them just the same. So if you visit our avx.com, you can see that we have a wide range of products. So today, I'm going to focus on one of our cloud enabler, which is a controller that it's deployed as a virtual appliance that is deployed in your data center. Okay, it deployed in your data center. So what does it do? So, so, so those are the couple of highlights. I like to say that we're very excited to bring this. We're very excited to bring this functionality and this capability to Azure. This product is not possible without the user-defined routing that is just being launched by Azure. We think that it is a significant step forward because without that, because Azure just built an engine for the ecosystem to run. Now it allows partners like us to play in Azure and build values and solutions and to Azure customers. And I also like to mention that this product is completely API, REST API driven. And Azure REST API is actually not difficult to use. When Narayan gave us the go ahead for the preview, we were able to turn around and set up, have pretty much everything working by the end of the day. So, of course, it's a very long, long day, but it works. Excuse me. So next, I want to go to the actual demo. So what we have here is we have a virtual appliance. Oh, sorry. So we have.
Yeah, it's fine.
Okay. Okay,
Yeah,
so.
just leave it here.
Okay, so we have a virtual appliance that is deployed in the Ignite network. It's basically a PC over here because it's a OVF or VHD. It can be deployed anywhere, and it creates a VNet in Azure. And in that VNet we have a application, web front application, and we have a database. And then we also have another VM. And we also have a backup database. Of course, Azure has many regions, and you can back up to many of the Azure regions. But say you're very paranoid, you worried about some guy in Azure push a wrong button that shut down the entire network. So no worries, you can back up to another cloud provider. In this case, it's AWS VPC. We support multi-cloud. We support both AWS and Azure from the same platform. So in this case, we have a backup database that is building, that we have a secure encrypted peering ability between the VNet and the AWS that we're doing a database sync up. Okay, so and what I wanted to show you is using the Azure's UDR, the user-defined routing. Here's another thing that's unique about the Azure UDR. It has the fine granularity that let you control even within the VNet if you want to route traffic through us and then to another server. And this gives us a unique ability to apply security policies or to supply, in this case, packet logging. That give you both security and visibility. In this case, we set it up the policy such that the database can only talk to the application, and the database cannot talk to this other VM. When the other VM try to talk to it, it will be blocked. And also the remote data, the backup database can only talk to the primary database, and the traffic will be blocked if a VM tries to talk to another backup database. And we also configure, we enable Splunk integrated with the Splunk forwarder that you can log your dropped package or even your entire events to be either forwarded into a Splunk server, or you can log into local, in that case, in the remote case, in the local system log. Okay, so with that, I want to show you So I want to switch to the demo session and show you. Okay. So here for the interest of time, actually setting up a VNet and setting up the entire functionality takes about 10 minutes. But in the interest of time, I already have it set up, so I can show you. In the Azure VNet, we have we have 3 subnets set up. One is a public-facing. No, it's okay. We have one public-facing subnet and private subnet. And in terms of the in terms of the instances, I want to show you. So the dashboard. So we have 3 instances. We have a database, and then we have a web-facing application, and this is our gateway instance. And we have a client, which we want to show that traffic will be blocked. And our application here is. We did a survey that we found all our audiences are wild soccer fans. So we put together a live fantasy soccer scoreboard, which shows all the scores all these superstar soccer players have scored since their birth time, and the scores are continue to increase if we refresh. So what I want to show you is, they have very good scores. So what I want to show you is this is there's some. So what I want to show you is here is my this is the gateway this is the virtual appliance gateway that I'm gonna SSH into, and I'll do a TCP dump to. It takes a little bit of time. While it's going up, I want to show you. So we have set up security policies such that it's okay. We have set up security policies such that we want to. So the security policy, it's a stateful firewall. It can do deny or allow all. In this case, we set up a allow all, and we have set up security policies such that the VMs cannot talk to the database. The traffic will be blocked, and it will be logged. To show you that. So for example, if I want to ping this, now I want to ping this database, of course the ping will fail, and if I do a TCP dump, so you can see that packet coming because it's routing through our virtual appliance, but there is no echo reply, ICMP reply. So now if I change my policy, I delete this security policy and I save it. Wait until it finishes. So now traffic could go through. And in the meantime, if you come to your Splunk logging, you will see that so you will see that the logged packet these are some plugins you can see. You can see the traffic logging from traffic coming from source 10.50, which is the packet count that if we refresh it, it's gonna go up. So it will give you visibility about what happened and what are the events. So likewise, if I want to, so now this packet is going through. Now, if I want to ping the remote database, which is the backup database, again, traffic is going through our router, but you're not seeing any success because the security policy blocks it. Now, if I want to come here, which is a AWS VPC, I wanted to, here's the stateful security policy. It says it's blocked. And I want to delete this policy just to be, and I save it. Of course, you can do, you can come back. So now the traffic is going through. Of course, you can always do the reverse action where you allow it to happen and you can deny it. So we have fine granular control of a stateful firewall, and you can show that going through the router. So, so I wanted to, so that's kind of conclude our demo. I wanted to talk a little bit about the use cases, how our customers have been using, hopefully can give you some ideas. First of all, the first thing you can use our appliance as for fast onboarding because it's so easy to deploy and it completely eliminates all the troubles you go through with the routing, with the BGP, with the firewall, and with buying hardware appliance. The appliance can be downloaded for free. So within minutes, literally, you can set up a VNet. You can start to explore Azure if you're thinking about it. So that's one use case people use us for. Another use case is, say you already have your virtual network in the cloud. You need to expand it. We have some very talented IT folks that they hand stitch it. They're so capable, they're hand stitch the whole network and set up secure tunnel, full mesh. But now they need to expand their business. And if you handmade your everything, whenever you need to expand, it becomes very challenging. So you can use our product very easily, systematically to expand. And there are other things you can do with our product. One of the application deployment practice in the last decade also is bring users to the app. You know how you always have your apps in a data center where you bring your users, whether from branch office or from remote places, to the data center. And usually the latency can be hundreds of milliseconds. So people spend millions and billions of dollars on WAN optimizations, on spending money on MPLS in order to get a reasonable user experience. But with the cloud, the whole deployment architecture can be completely changed because Azure has so many regions worldwide. You can put your apps close to the region where users are. Instead of bring user to the app, you can now bring apps to the user. So you solve the problem by eliminating the problem. So that's one, going forward, that's how apps are going to be deployed. And another use case you can use is because the VNets are so easy to create and they create natural boundary for security, you can actually put your apps into separate VNets, and that improve your application security by isolation. Microsegmentation is something you hear from data center. You can do this with VNet. And some other capabilities, you can give your developers their own sandboxes because today all the apps are very complex. They require multiple VMs. The developers can have their own environments, so you can have their own sandbox let them play. So these are the use cases you can think about. So cloud is not just a data center that you launch. Cloud is, many data centers, unlimited supply of resources that you can leverage that can totally change how you do things. So hopefully this gives you some ideas and inspirations for you to explore the power of Azure. So that's it. Thank you.
Thank you, Sherry and Pankaj for this good demo. So before I actually summarize, I just want to take a moment to kind of show you what they just did and what enabled them to do that. So bear with me for a minute. So this, okay, is it playing here? Not yet. Okay. Maybe this is the video I need to play here. Okay, so this, what you saw here was the package that was leaving this VM and the web server in the Azure VNet, instead of directly going to the database, it went through the appliance that Sherry had. That is the Aviatrix appliance. And this was made possible by this route that is defined over here. Look at this route. It says anything that is going to this address prefix that is on this subnet, right? The next hop type is a virtual appliance. That's what you're referring to this guy over here saying this is the virtual appliance, and the IP address is 48.4. That's the IP address of this virtual appliance. So you're saying that the traffic from going from here to here that would have gone directly is now going through this appliance. So she took over the traffic flow in her VNet to have every single packet go through her. Not just those packets, but also by doing other cloud providers like AWS over here. Even the packets going to the other cloud can be made go through this appliance. So you totally control the traffic flow in your virtual network to go through your appliance. And that's when she showed you that she can actually see all the packets going. When she did the TCP dump, that was on the virtual appliance, and you could see all the packet going. The source and destination actually was the web server, the client to the database, right? But it was going through this appliance. And she had the power in her console to just turn it off or turn it on. And not just that, she enabled packet logging, where there's actually stored every single packet that is allowed or denied. It's actually stored in the local VM. It's also sent to service like Splunk, where you can actually look at them later and do data analysis later, right? That is the power of user-defined routing. We have really opened up the traffic flows to you for you to control and take total control of your virtual network. That's what the point I want to just re-emphasize. So now, how do I put this all together, right? So if I were you, I'm like, okay, I have this on premises, right? I'm happy with it. I'm over there. Everything is running fine. How do I actually migrate into the cloud, or where do I start, right? If that's your question, you have to start by creating your network, right? You define your network on Azure. That's your virtual network. Next step is to define subnets, do segmentation, right? The networks are not flat. Like, do your subnets, segment your network. The next thing to do, even before you, then you deploy these virtual machines into these subnets, right? You deploy, if it's front end, deploy them into the front end subnet. If it is app subnet, deploy it in the back end subnet. So deploy your virtual machines after you define your segmentation. Now, also then put security policies now using security groups, right? What we provide, what Azure provides. That's the network ACLs. Put your network ACLs there on the subnets just to make sure like who can talk to who. The next step is, if you have a front end facing layer, then do a WAF or something like that if you want application firewall, and then use our load balancing abilities to direct traffic to more than one instance and let the traffic flow. Now you got yourself a DMZ. This is your DMZ, and whatever security rules that you want, you can do it in two levels. One is network ACLs using security groups. If you want something more than that, yeah, bring one of the appliances and do application level firewall using like a WAF or something. Now you got your DMZ. Now, if you want to do like high availability on your internal services, right, use the Azure's internal load balancer, which is a private IP load balancing, and then that way you can get a really highly available services running on your backend. And the last thing is, use user-defined routing to bring even more appliances like a NAT device. So any traffic going through your internet, make it go through your NAT devices where you have complete control, like the demo that you saw. Take control of your traffic and take the necessary action that you want. And last but not least, stay connected, right? We provide a lot of solutions in the hybrid way, express route, site-to-site VPN gateways, connect it back to your on-premises, stay connected. You have an environment that you can work with, and you should be doing that. So here are some of the customers who are using virtual network on these abilities. I mean, we have a lot of customers, just chose to name a few over here that you can recognize, right? So hopefully you are one of them. And there is tons and tons of resources for you to find more about like security. And let's say you're an architect, you're now trying to design and move services into the cloud. If you have questions on where do I start, because of course information can be sometimes intimidating if it is too many of them. So there is really good guides here. Just like read the guidelines to see like where you start, how you architect these things. And I just want to, this deck will be available to you later where you can actually go through them and click on the links and learn more. Just wanted to put it over here, just like a reference point. So we have all these things available for you. And sweepstakes, with the end of the conference, probably already done it already. If not, there is that. Do your evals. Definitely do that. Feedback is very important for us. We try to improvise every year. We want to give the right content to you in these sessions. So please take your evals. And I'm here for any questions, and please be open. Yeah, thank you. Yeah, number one. There's a question there. Oh, sorry, I couldn't hear you. Can you use the mic or something?
Can you upload the presentation because it's different than one I downloaded?
Oh, really? I'll make sure this presentation is what you can get your hands on, so don't worry about that. So you will have this presentation that you can download later. Yeah.
User-defined routing.
Yes.
So, Jason, PowerShell, how do you?
Good question. User-defined routings. How do I use that? Is it available through JSON-based templates today? Today, it is not. But it is coming to JSON-based templates very soon. Today, you still have the old way of REST-based APIs that you talk to the Azure front ends. You can call REST-based APIs. There are samples on the web on what APIs you call, so you can get it through that. You do have PowerShell. You can use PowerShell to also configure user-defined routes. What is coming is the portal presence is coming, and we are also going to make this available through our ARM model, the resource manager. So you will have like JSON-based templates, and there'll be samples. I'm sure I'll make sure there are samples there for you to use. So we will get that all in the future, very soon. Okay, so another question? UDP support for, yes, so we do like TCP UDP support. So yeah, of course you can use it, layer 4, yes. Okay, so where is user-defined routing available? So you might have seen the service update that we posted yesterday or day before. Currently it's only available in 6 regions, right? Just as a flighting thing that we do. So we are released that to 6 regions, not just North Central US. It's available in Japan West. That's where they show the demo. The demo they showed was actually on Azure, public Azure on Japan West. That's where I showed the demo. It's available in Japan West, Japan East, a couple of Australian regions, Brazil, and also like North Central US. And every other region is catching up, and we'll do it very soon. Yep. Any other questions? And we'll also stay here if you want to talk more, then we'll be here. But yeah, another one.
Are there limits or performance considerations to the number of network security groups that you
There are limits. So you can have as much up to 200 security groups today in a subscription. And each security group, you can define up to 200 rules, right? And I would say most time that is more than enough. It's more than what the competition offers. And whenever I talk to people, you can always get your rules within that. But for some reason, if you need more rules, you can actually increase it up to 400 through a support ticket. So that's where we are with limits. And with respect to performance, all the measurements we have done, absolutely none. Because we do this on the network level, right? It's just a lookup for us. It does add a little bit of lookup time, but not noticeable at all. I mean, it don't have any impact in performance just because you security groups. No.
It's all wire speed.
Yes, it's all wide speed. Yeah, great. One more question? Yeah.
Do you have any resources for people who are used to like Cisco networking?
Yeah.
To do, like, if I go to my network guys and say you're going to have to learn how to use JSON instead of a running config, like, how do you do that?
I got you. So for people who are so used to Cisco type of networking configurations, how do we graduate and use this JSON templates, right? We take a lot of care to make sure that this is intuitive and there are a lot of samples for you to actually follow, right? But if there is something where we can actually map what the network admins know about to see how this actually maps in this latest, we could build out some article or something like that to kind of a guideline as to things that you have done like this over here. It's probably this is the way to do it. We can think about publishing some articles. It's a good feedback. But generally, it's so intuitive and easy to follow, and with a lot of samples. I mean, it's not that difficult. Oh, there's okay. Thank Vijay for reminding me. There is actually a talk just on Azure Resource Manager and network resource providers today. I don't know one of the exact room, but it's at 3:15. It's from one of my colleagues. So please attend that to get more information.
Okay, thank you.
Yeah. Cool.
So the Aviatrix and UVR both the same, or
Sorry?
Aviatrix
Yeah.
and UVR
Yeah.
both the same?
No. Aviatrix is one of our ecosystem partners who have built a solution using user-defined routing. User-defined routing is a feature that Azure infrastructure provides for anyone. We have a lot of our ecosystem partners who are building solutions on top of that. Aviatrix is one of them. That's what you saw today in the demo. Yeah. All right. This is great, guys. It was great talking to you, and hopefully you got some good information out of the session. And as always, please reach out to us, a couple of links, and stay connected. Thank you.